Okay, good morning class. Right. So today we will learn new chapter. Okay, chapter 5. Okay, thermochemistry. So before I move on to the new chapter, okay. So I already assigned. Okay, I already assigned a homework for you. Okay, for chapter 5. Okay, exercise for chapter 5. Okay, so what I want you to do is wait for a moment. Okay, so for this exercise, okay, you can print. Okay, so for those who don't have a printer, okay, you can just write the answer, okay, on the test pad, right? And no need to copy back the question. Okay, just write the answer. Okay, and then you scan your answer. Okay, scan your answer and change it to PDF. Okay, so you can use the cam scanner apps, okay, and take picture, then it will turn to PDF. Okay, after you change the format to PDF, so you can turn in. Okay, so please don't send me the image in the image form, okay, because after, if not, I have to convert. So every page that you send, I have to convert to PDF. Okay, so just convert first to PDF, then submit to me. Okay, so let's say for this one, this is the exercise, okay, for chapter 5. Okay, so for those who have printer, you can just print out and answer here. Okay, for those who don't have a printer, you can just like put 1A. Okay, so what's the answer? Okay, 1B, what's the answer? Okay, and for number 2, okay, just give me the answer that you feel. Okay, that you fill the blanks. Okay, so you don't need to copy back all the answer. Okay, so that is your homework. So I give you like, I think, until tomorrow to submit it. Okay, so please submit it according to the time that I already given. Okay, so that's for the homework, okay, for today. All right, so we move on to the new chapter, right? Chapter 5, thermochemistry. Wait for a moment. Okay, so endothermic and exothermic reaction. So before I teach, okay, before I explain to you what is endothermic reaction and what is exothermic reaction, so let's see what is actually a thermochemistry. Okay, so thermochemistry is the study about heat changes, right, during chemical reaction. So thermo means heat. Okay, so thermo is mean heat. So it's heat, whether heat is released, okay, or absorbed, okay, during chemical reaction. So let's say for the example, when you add natrium hydroxide, okay, through water, okay, so there will be a chemical reaction occur. So whether the heat will be absorbed or the heat will be released, so that is the thermochemistry. Okay, so the thermochemistry is the study about heat changes during chemical reactions. Okay, so heat change in a chemical reaction. So heat or energy change occurs in most of the chemical reaction. Okay, so there will be maybe the heat will be absorbed or maybe the heat will be released. Okay, so mostly for the all chemical reaction, okay, there will be the heat release or the heat absorbed. Okay, and when the chemical reaction occurs, heat is absorbed or released. So this one I already explained. So heat is absorbed to break the bond in the compound. So conversely, heat is released when the bond is formed. Right. So example, right? Example, the easy example that I can give to you. Okay. So let's say I have a ice, right? So ice, okay, ice change to water and water change to the water vapor. Okay, it's changed to the water vapor. Okay, how does it mean? What does it mean by when the heat is absorbed, the chemical bond is the chemical the molecule bond will be break. Okay, and then if the let's say from the water vapor change to water, okay, the chemical bond will be formed. Okay, so what does that mean? So let's say this is the ice. So you know ice is in solid form, right? And then water is in the liquid form. Okay, liquid form, while the water vapor is the gas form. Okay, and I think you already know that solid, okay, solid, the arrangement of the molecule is very close to each other. Okay, while the liquid is freely moved, okay, and it's further from each other, but for the gas it's much further than liquid. Okay, so it's more freely than liquid, okay, for the molecule movement. Okay, so let's say from the ice to water. So ice to water, the heat will be absorbed. Okay, the heat will be absorbed. So when the heat being absorbed, okay, so what does the function of the heat that it absorb? Okay, so that one is actually to break the molecule bond between the molecule bond. Okay, so it can move freely. So the heat is used to break the molecule bond because solid is actually very close. So if you want to change to liquid, so to like move freely, so it needs to break the molecule bond. So the heat being absorbed to break the molecule bond here, so it can move freely like in liquid. Okay, so it's same also like when the liquid want to change to gas, right? So from water change to water vapor. So you can see the molecule here is much further. So it means you need to absorb the heat, okay? So it can move freely like gas. So this one also heat is absorbed to break the molecule bond, so it can move freely like gas. Okay, all right, so how about when the gas change to liquid? Okay, so when the gas change to liquid or water vapor change to water, so for this one the heat is released. Okay, so the heat is released. So when the heat is released is to form the new molecule bond. So you can see here from the gas to liquid, so it now it want to move closer to each other, so it needs to form a bond. Okay, so it need to form the bond. Okay, so that's why when heat is released it will form a bond, so now it will move, it will be much closer to each other. Okay, and same also when the liquid change to solid. Okay, so when the liquid change to solid, now it want to be more closer, so more closer means it need to form a new bond. Okay, so that's why the heat is released here. Okay, so later we will see whether this one, which one is endothermic and which one is exothermic. Okay. Okay, so chemical reaction can be classified into two types. There is a exothermic and also endothermic. Okay, so the chemical reaction are applied in the making of hot and cold packs. So let's say if you enter the running competition, right? So means you need sometimes, okay, when if you got hurt, like when if you have a swollen, okay, so you need to use the cool pack, right? Okay, so or hot pack. Okay, so this is the function of the endothermic and exothermic reaction. Okay. Okay, so let's see the first one, exothermic reaction. Okay, so a reaction that release heat to the surrounding. Okay, a reaction that release heat to the surrounding. So exothermic is actually you release heat. Okay, so you release heat from the surrounding. Okay, release heat to the surrounding. So when you release heat the surrounding, so your surrounding will become hot. Okay, so it will when it become hot, the temperature will increase. Right? Okay, so I explain again. So the exothermic reaction, okay, is the reaction that release heat to the surrounding. So the surrounding will become hot, okay, and the temperature will increase. Alright, so when this reaction occurs, the reactant will lose heat to the surrounding. So since heat, okay, is released from the reactant to the surrounding temperature is raised. Okay, rise. Okay, so it will be raised lah, right? So let's say from the 20 degrees Celsius, we raise until 40 degrees Celsius. Okay, so like that. Okay, so next one. So the content and the container become hot. So as a result, the container also feel hot when touched or shows a higher temperature when measured with a thermometer. Okay, so and then the total energy content of the product is less than the total energy content of the reactant. Okay, so since it released the heat, okay, so it's since it released the heat, okay, so before the reaction, okay, the temperature, okay, the energy, not the temperature, the energy is much higher than after, because there is a loss of energy there to the surrounding. So the total energy will become decreased after the reaction, okay, because there is a loss of heat, right? So example of the exothermic. Okay, so the example of the exothermic is burning of pepper, okay, burning of pepper, and also explosion of bomb. Okay, and then another one when you dissolve the sodium hydroxide pellets in water. So all this will release the heat. Okay, so all this will release the heat. Okay, and the temperature will be rise. Okay, the temperature will be rise, and the molecule bond will be break. Okay, so this is the another example, right? Okay, this is the another example for the exothermic. So addition of natrium hydroxide to water. So when you add the sodium hydroxide, okay, pellets, okay, so the mixture is carefully stirred to dissolve the pellets. So the temperature of the water is recorded before and after adding the sodium hydroxide. So you can see there is an increase of temperature. So later we will see the experiment. Okay. All right, so the next one is an endothermic reaction. Okay, so endothermic reaction is the reaction that absorb heat from the surrounding. Okay, so absorb heat from the surrounding. So when it absorb heat from the surrounding, means the surrounding will lose the heat. So when you lose the heat, so the temperature of the surrounding will become decrease. Okay, it will be decrease. Okay, so I explain again. So since the endothermic, it absorbs the heat from the surrounding. Okay, so the temperature, okay, of the surrounding will become decrease. So it become cold, right? So when this reaction occurs, the reactor will gain heat from the surrounding. So the content in the container become cool. So as a result, the container also feel cool when touched or shows a lower temperature when measured with a thermometer. So when you measure a thermometer, you can see the temperature will be decreased. So it become cool. Okay, the container, if you touch the surface of the container, the outside surface, so you can feel it's very cold. So later we will see the experiment about this one. So the total energy content of the product is more than the total energy content of the reactant. So means the total energy after the reaction is higher than before. Okay, because now it absorbs the energy. Alright, so the example of the endothermic, okay. So the example is photosynthesis. Okay, so photosynthesis means it absorbs the light energy. So the light energy is the heat energy, right? So it absorbs the heat. So that's why it's an endothermic. Or you can see like you're baking a cakes. Okay, so it absorbs the heat energy from the hot air from the oven. Okay, or you dissolve the ammonium nitrate powder in the water, and the breakdown of reaction of metal carbonate. So this one already learned in the chapter 4, right? The reactivity of metals. And also you making instant cold packs. Okay, so this is the example of the endothermic reaction. Okay, so photosynthesis, you absorb this light energy. So the light energy is essentially also in the heat energy, in the form of the heat energy. So you're baking a cake. Okay, so that's all for the chapter 5. Okay, that's all for the chapter 5. Okay, so let's see the video. Okay, to make you more understand. For a moment.
Depending on the absorption or evolution of heat energy. Exothermic and endothermic reactions. Depending on the absorption or evolution of heat energy, we can classify reactions into two types: exothermic and endothermic reactions. Exothermic reaction describes a process that releases energy in the form of heat. Burning of fuel is exothermic. Endothermic reaction describes a process that absorbs energy in the form of heat. Melting of ice and evaporation of water are endothermic. Let us look at a few examples of exothermic reactions. Take a matchbox and strike the matchstick on its side. The matchstick burns, giving out a lot of heat.
Okay, so this is the
Let's watch
example
this
of the
dramatic
exothermic
example
reaction.
of an exothermic reaction. The dehydration of sugar with concentrated sulfuric acid.
So sugar with
Let's
the
take some
acid
sugar in a
had
beaker.
sulfuric acid.
Add 8 to 10 drops of water to the sugar in the beaker and stir it well with glass rod to moisten it. Now measure 30 ml of concentrated sulfuric acid in a measuring jar and add the acid to sugar. Stir quickly. See that acid covers sugar. Stand back and observe. Sugar starts changing color and finally turns black and rises in a column, releasing steam and a pungent smelling gas. The black mass left behind is sugar charcoal, a form of pure carbon. This dehydration process is a highly exothermic reaction, turning
This
water
is
content to steam.
exothermic reaction means it
It's time to
releases
look at some endothermic reactions
the
now.
energy.
As you
So
know, these
it
reactions
will
absorb
increase the
heat energy.
temperature.
Look at how an egg is fried on a pan. When we break an egg on a heated pan, heat is absorbed by the egg and the liquid parts turn solid.
Okay,
Remember,
so the
it is
endothermic,
always not
it absorbs
necessary
heat.
to have a dip in temperature, but many endothermic reactions require constant supply of heat till the reaction gets over. Let us understand another reaction where there is absorption of heat.
So this one you can do
Pour
in
about
your
50 ml of
house.
vinegar into a beaker. Place a thermometer in it and note down the temperature.
You
Now
put the
carefully
vinegar
add 2 or 3 spoonsful of baking
and
powder
baking
into
powder.
vinegar. Instantaneous reaction with brisk effervescence takes place and the solution almost fills the beaker. Stir the solution and note the temperature at the end of the reaction. During this reaction, heat is absorbed and temperature reduces. Therefore, the reaction of baking powder with vinegar is an endothermic reaction. Observe some reactions taking place in your everyday life and classify them as endothermic
So
or exothermic
photosynthesis, the
reactions.
endothermic, right? Melting of wax also is the endothermic. Okay. So this is the exothermic and endothermic. Okay, so let's watch another one, the last one for the experiment. Okay. So for a moment.
I'm going to do today 2 experiments to demonstrate.
Okay.
First, we are going to do an endothermic reaction.
So this is
where
the
I have barium
endothermic
hydroxide,
reaction. Okay, barium hydroxide,
ammonium chloride together.
barium hydroxide and ammonium chloride. So if we add the barium hydroxide and the natrium chloride, okay, so inside the beaker. So this is actually the endothermic reaction.
hydroxide in this beaker.
So let's see what happens in the endothermic reaction.
And in another beaker, I will add ammonium chloride.
Okay, I just fast forward the video. We just see the reaction.
To make it
Okay, so it will put some water, okay, on the wooden block. Okay, so let's see what happened to the water, okay, that it puts on the top of the wooden block.
I pour some water on it. Now I'll place the beaker containing the barium hydroxide.
Okay, barium hydroxide and ammonium chloride.
Placing the temperature sensor.
So this is actually the
for
temperature sensor,
the
right?
beginning of the
So it
chemical
will give the
reaction.
reading here.
It is now
Okay.
around 24 degrees Celsius.
So this one now is a 24 degrees
Now I'm
Celsius.
going to add the barium, the ammonium chloride.
So we stir the barium chloride and the barium hydroxide and the ammonium chloride.
Very fast.
So you can see,
Temperature started to drop.
okay, the temperature start to drop. Okay, so you can see just now is 20, right? So now it become 4. So means this is endothermic. So it absorb the heat, okay, from the surrounding. So now the surrounding become cold. So the temperature will drop.
It's going to go below 0. At this point, water will freeze.
Okay.
So it's like a white liquid now. And the beaker is very cold.
Okay. So it will keep decreasing. So now I can see until negative 12. Okay. So what I want you to see what happened to the water that you put on top of the
Temperature keeps on dropping.
that you put on top of the wooden block. Okay. So let's fast forward it.
Lift this up.
Okay.
And
So
I expect the water that was between the beaker and the
it will freeze. The water will freeze. So you can see it's thick. Okay. So now the water becomes solid.
We try to separate them. It's just sticking. This is the
Okay.
So
So you can see there is an ice form here. Okay, because it's too cold, so it will be the water on the top of the wooden block. Okay, it will become solid, right? So it become ice.
we go. Absorb the heat that was in the water.
Okay,
And
so that's
turn
a to
from
ice.
liquid to solid.
Okay, so let's see for the
The
next
second experiment is
exothermic reaction. Okay,
chemical reaction. I have here calcium carbonate.
okay, calcium carbonate. So this one is a metal carbonate, right? React
I'm
with
going
the
to add concentrated sulfuric
acid, sulfuric acid, right? So the metal carbonate, the calcium carbonate react with the sulfuric acid.
Celsius.
So just now the initial temperature is 22. So let's see what happens when you add with the sulfuric acid.
Forming.
So you can see the bubble of gas there.
It's turning. The beaker is turning hot.
So you can see now the temperature rise
The
until
temperature
40.
is increasing.
Okay, 40 degrees Celsius. So this one is an exothermic reaction.
From
Okay,
it was
so exothermic reaction, you release heat to the surrounding. So now the surrounding become hot. Okay, so what is the function that the heat being absorbed? The function of the heat that being absorbed is to break the bond of the molecule. Okay, so that is the exothermic and endothermic reaction. Alright, so to make sure that you really understand, okay, to test whether you understand or not. Okay, so I have a quiz. Okay, so I will call randomly. Okay, people to answer the question. Right. Okay. Wait for a moment. Okay, for the first question, I would like to call Chen Wai Hong. Okay. Before that, monitor, please take the attendance for today, right? So Chen Wai Hong. So are you here, Chen Wai Hong? Okay.
Yes,
So
yes, yes.
yeah, can you give me the answer for the question? So the diagram shows the bread dough is put into the oven to be baked. So which statements are correct about the baking process? Choose more than one answer. So this one is seem like you bake the cake. So whether the heat is absorbed or the heat is released. And how about the temperature of the surrounding? So whether it is endothermic or exothermic.
2 and 4.
2 and 4. Oh, so is this endothermic or exothermic? So only 2 and 4. That is your answer. Right. So it's okay. So let's see whether it's correct or not. Yeah, actually this one is the endothermic because you absorb the heat from the hot air, okay, from the oven. So this is the endothermic. So you miss one answer. Okay, that is the endothermic reaction. Okay, so another question for Brian Tanjanzi. So endothermic is a reaction that absorbs heat. Is it true or false? Brian Tanjanzi. So are you here? Yes, true. Okay, so endothermic absorb heat. Okay, correct. So endothermic absorb heat, exothermic release heat. Okay, for number 3, what is the use of the hot pack? Okay, so Cheng Kai Hui. What is the function of the hot pack? So which one is the answer? Relieve joint pain. Okay, correct. So when you put the hot pack here, it will be expand, right? So means that more blood can flows. Okay. So choose the tools that apply the concept of thermochemistry reaction. So for this one, I would like to call Chu Yi Wen. Chu Yi Wen. The concept of thermochemistry reaction. So which one? Third one, instant cold bed. Okay. So for this one also use thermochemistry. Okay, so it absorbs the energy. Okay, so the temperature of the substance in the reaction remain constant after reaching the thermal equilibrium. So I would like to call Pavandip. Is it true or false? It will remain constant after reach the thermal equilibrium. False. Okay, so the answer is true actually. Okay, but you choose false. The answer is true. So when an object is reached the thermal equilibrium, so the temperature will become constant. It's just same like if you mix the hot water and the cold water. So the temperature will be let's say for the hot water it will be decreased, right? And so the until the both of the water have the same temperature. Okay, so that is the thermal equilibrium. So the answer should be true. Okay, the next one, which of the following is an endothermic reaction? So the answer is, the Wong and Tong. So which of the following is an endothermic reaction? So endothermic reaction is absorb heat. So the temperature will become, if the temperature will decrease, the surrounding will become cool. So which one is the answer? Which one is absorb the heat? Photosynthesis. Yes, correct. Okay, this one I already explained. It absorbs the light energy. So the light energy actually is a heat energy too, right? Okay, the next one, respiration is an exothermic reaction. Which of the following explains the process? Okay, so I would like to call Poon Yan Chong. Okay, Poon Yan Chong. So which of the following explains about the process? Exothermic release the heat to the surrounding. Release heat to the environment. Very good. Okay, for number 8. So for number 8, I would like to call Annabelle. So which statement is correct about the endothermic reaction? So endo, which one is correct? So endo absorb heat. So when it absorb heat, what happened? Number 1, so it will break the chemical bond of the reactant. So the energy that being absorbed is used to break down the chemical bond of the molecule bond. Alright. So for this one, so this one and this one, right? Okay, so the next question I would like to call Yong Zi King. Yong Zi King. So the diagram shows a chemical reaction. The initial temperature of distilled water is 27. So what temperature may be recorded by the thermometer in the sodium hydroxide solution? This one is like the ammonium chloride and just now we see the video, right? They use the ammonium chloride and also the another one is the sodium hydroxide. So number 4. Okay, yes, the temperature will be, so the temperature will be increased, right? Not decrease. Okay, so which process does not involve the release of heat energy? So the release of the heat energy, the answer goes to Chong Xin Yi. So which process does not involve the release of heat energy? So this one must be exothermic. So which one is not an exothermic reaction? So the temperature of the surrounding will not increase. Number 1, melting of butter. Melting of butter, it absorbs heat, right? So that one is the endothermic. So actually the answer is yes. Melting of butter. Okay, so the diagram shows the setup of apparatus for an experiment. So which of the following experiment is true about the reaction that occur in the experiment? So I would like to call Ang Wei Ru. Number 1, the heat energy is absorbed from the environment. Okay, very good, correct. Okay, number 12, breaking the bond release energy. So for this one, I will like to call Cheong Heng Sheng. So when you break the chemical bond, it will release energy. Is it correct? Yes? Which one is your answer? False. Okay, breaking the bond, chemical bond is absorb energy. Release energy if you want to form a bond. So the answer is false. Alright, the next one, I would like to call Ng Fei Ying. Ng Fei Ying. Sublimation process that occur in the dry ice. So this one from the solid change to the gas. So this process is endothermic. Why? Endothermic is absorb the heat. So the correct answer is number 1. Okay, very good. Okay, number 14. How can we identify the absorption of heat has occurred? So the question goes to Lua Meng Sun. Lua Meng Sun, how can we identify the absorption of heat has occurred? So when the heat absorbed, what happened to the temperature of the surrounding? Number 1, the surrounding temperature decrease. Yes, very good. Okay, for number 15, okay, I would like to call Ng Junyuan. So which reaction have to explain about the exothermic reaction? So exothermic reaction, so which one? Number 2, surrounding temperature increase. So it released the heat to the surrounding, the surrounding temperature increase. Okay, correct. Okay, and then the last one. So what happened when the heat energy absorbed? So I would like to call Song Jia Jun. Song Jia Jun. What happened to the heat when heat energy is absorbed? What happened to the heat energy? What does the heat energy do to the chemical bond? Bond formation occurs. Okay, so remember just now I told when you want to form a bond, the heat must be released. If you want to break the bond, you have to absorb the heat energy. So the heat energy that actually being absorbed is actually used to break the molecule bond. So what happens when the heat energy is absorbed is that one is actually to bond breakage occurs. Okay. So that's all for today. But before that, I would like to see for this one. Okay. So heat absorbed. This one is actually endothermic. Okay, and also this one also endothermic, and heat is released, so this one is exothermic, and this one is also exothermic. Okay, so I hope you understand what is actually the exothermic and endothermic. So the characteristic of the exothermic, it will release the heat. Now the temperature of the surrounding will become increased. Okay, and the heat is absorbed to use that is used to break the molecule bond or the chemical bond. Okay, for the endothermic, okay, so that's why is for endothermic, but for the exothermic, the heat is to release, okay, to form the molecule bond, okay, and the temperature of the surrounding will be increased. Okay, so that is the exothermic and endothermic. Okay, so I think I will stop here. So please do the exercise for the module chapter 5. Okay, so submit. I give time until tomorrow. Okay, so I see you later on. The next class is on tomorrow. So for tomorrow, I will assign for you. And before that, before I forgot, I will send the second quiz, the checkpoint 2. Okay, in the GC later. So please answer that one. Okay, the checkpoint 2. Just now you answer for checkpoint 1, right? For this, after this, you will answer checkpoint 2. So I will assign it on GC. So please answer the question also. All right. And please use my email. Okay, I will put my email on the GC, on the GC later. So you enter my email so I can know what is your marks for my record. Okay, so thank you class. All right, so see you tomorrow. All right, welcome. Bye.